Hi class, it's me, Miss Null. I hope you all had a wonderful long weekend and welcome back to class. Obviously I'm not here today, but I did want to just kind of review with you the best that I could on things since you haven't seen this in about a week. Hopefully you've been looking at the review and studying the material, but just kind of to give you a refresher. I wanted to go over a few problems. So I want to start on this page. So for the review of whether it is a function or not, if you have a graph, you want to see if it passes the vertical line test. So for the vertical line test, that is if you imagine a bunch of vertical lines. So it fails the vertical line test if any of those lines passes the graph in 2 points. So when that's the case, it is not a function. Now when you have x's and y's, as in next examples, if you have a repeat of the x values, and it's going to 2 different y values, then that is not a function. So if you look at the second problem here, we have 1, 2, 3, 4, 5, 6 in the x's. There's no repeat, and they're all going to whatever y, it doesn't really matter. And so that is a function. But looking at the third example here, we have x, 1, 2, 3. Oh, but 3 has 2 different arrows coming from it. It's mapping to 0, and it's also mapping to 4. And so because of that, that makes this not a function. So that would be your answer for those. Now it doesn't matter if the y repeats. I think there's an example of that right here. Yeah, so if you look here at this problem, we have 3, 4, 7, 9, 2, -4, and 5, -4. So this -4 repeating here in the y values is not a problem. That is still a function. It's only if the x repeats. Okay, so now we did go over this problem in class. So you want to graph and then talk about domain, range, and behavior. So hopefully that is kind of fresh in your mind. For lines, unless it's vertical or horizontal, you're always going to have a range of all real numbers, and that's always negative infinity to positive infinity. So the negative always will come first, and then the positive infinity. So then these examples are very similar. So continuity, whether a graph is continuous or discontinuous. Basically, if you can draw the graph without lifting up your pencil, it's a continuous line. If you have to pick it up because of a jump or a hole, then that makes it discontinuous. So, for example, this first one here, if I retrace this line quite poorly, you would see that I never had to lift up my pencil, and so that would be a continuous line. But on the other hand, here on the next one, I have following that, and then I have to jump down here, pick my pencil up, and draw the rest of it. And so that would be a discontinuous line, or curve. Okay, I do want to do a few of these problems. So let's say you're given the slope of a line, and it goes through a point. So number 6, for example, we have the slope is -1, and it goes to the point 2, 0. So we start with knowing that we have y equals mx plus b, right? So the slope stands for m, and then the point 2, 0 is x, y, as points always are. So we're going to use this information, plug all these variables in. So my y value is 0, m is -1, x is 2, and I'm solving for my unknown, which is b. So I have 0 equals -2 plus b, and then I'm going to add 2 to both sides. Let's cancel out, so I have 2 equals b. But that's not my final answer. I need to write this all as a y equals mx plus b form equation. So I'm going to have y equals -1 x, and then plus b. So my answer is y equals -x plus 2. Now remember, there's an invisible -1 there in front of the x. Now sometimes we have fractions like number 7, so the slope is 5/9. So I'm going to have y equals 5/9 x plus b, and I'm going to use this xy point to plug in my values. So I have 4, plugging in for y, equals 5/9 times 10 plus b. Now this is a case where I personally would want to get rid of my fraction, the 5/9. It's just kind of annoying in my book. So I would multiply everything in the equation by 9. So I have to make sure I multiply the 4 by 9 and this whole side by 9. So what's going to happen is when I distribute this 9 to the 5/9, that will cancel out. So 4 times 9 is 36 equals, but I still have this 10, so I have 5 times 10, which gives me 50. And then I have to also make sure I multiply the 9 times the b as well. So I have 36 equals 50 plus 9b. So I'm going to subtract 50 from both sides. So that's going to be negative 14 equals 9b. And then I'm just going to divide by 9 on both sides. So b is negative 14. Nice. So don't fear fractions too much. They're really not that bad. So then my final answer would be y equals, so 5/9 x minus 14/9. And then I would put a box around that. So that's kind of how you want to do those ones with fractions in them. Now, if they give you 2 points and you want to find the equation, you have to first find the slope. So for example, number 9, I would have to find the slope, and to do that we take y2 minus y1 divide by x2 minus x1. So it's the change in y over the change in x. So here we have x1 comma x1 comma y1, and then here we have x2 comma y2. Sorry, this is a y1. Okay. And then, so I'm going to take y2 minus y1, so that's 9 minus 3, divided by x2 minus x1, so we have 2 minus a negative 2. So what happens when we have 2 negatives? It becomes positive, yeah. So we have 9 minus 3 is 6, over 2 minus negative 2 is 2 plus 2, which is 4. So I'm going to reduce that to 3 over 2, 3/2. So then from there, that is my slope. So I have y equals 3/2 x plus b. And again, I need to take one of the points and use those x, y values. Now it doesn't matter which point I choose, I just have to make sure I choose one of them and stick with it. So I'm just going to go ahead and pick the first one, plug in 3 for y, and negative 2 for x. So I have 3 over 2 times negative 2 plus b, solving for b here. So this is nice because the 2 and the negative 2 basically cancel out. I mean, the negative stays there, but I have 3 equals negative 3 plus b. So I'm going to add 3 to both sides. And this becomes b equals 6. So I have y equals 3/2 x plus 6. Yay! And that's my final answer. Alright, and so that is how you would do that. Number 12, I kind of tried to give you a hint here for pick 2 x, y points. So really, they're just giving you points here, like this is 2, 7. Here's 3, 10. So what I would probably do is just use those 2 points, find the slope, just like I did in that previous problem. Use that, use one of the points, plug in the x and y, solve for b, and you basically have that equation. Number 13, just remember, so we have hoi bucks. So when you see a vertical line, that tells us bucks, right? So that means we're going to have x equals whatever the x value is. So in this case, we have 2. So this is hoi, so following a similar pattern. Hopefully you can figure that one out. And then this is just a normal graph, so you'll find the y-intercept and then the slope. Okay, but I do want to look at number 16. So we have this friend, Michelle, and she is selling bracelets for $20, but it costed her $100 for all the supplies. So if you were setting up this equation, right, we have her profit, which is what we ultimately want to represent, and then the other variable, the independent variable, is how many bracelets she's going to sell. So I would make, I don't know, whether you call it Y or not, it doesn't really matter, but I'm just going to call it Y is going to represent the profit, and then X would be the number of bracelets. So her profit is going to be, each bracelet she sells, she gets $20 for, so that'd be 20 times X. But it costed her $100 for all the supplies. So if we're thinking about profit, $100 is going to be taken away from that because it was her cost. So we're going to subtract 100 from that. So this tells us that our slope, or I'm sorry, our y-intercept is actually going to be in the negatives. So when we're graphing this, X represents the number of bracelets, right? Bracelets. And over here on the y-axis, we have, sorry, that says profit. And that is represented in money amount. My pen kind of gave out there. And then, I want to see if I can make this skinnier. Okay, so then for the X values, right, she can just kind of sell like one at a time, one bracelet at a time. So we can just count by ones here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc., etc. Actually, I should probably keep going. 11, 12, 13, 14. Alright, great. And then on the y-axis, we have her profit. So since she's selling them for $20, we probably would account by something like 10s or 20s. We want to at least get down to negative 100 so that we can plot our y-intercept. So I'm just going to count by, let's do negative 10. So negative 10, 20, 30, 40, 50, 60. And then we'll go up by 10s, 10, 20, 30, 40, so etc., etc. Okay, so if I want to plot this, I have to go down. My y-intercept is at negative 100. I'm going to put a point there, and the slope is 20. So that's 20 over 1, and that means 20 units. So I'm not going to go like all these 20 squares. I'm just going to go up 2 because that represents 20. And then over 1. And then up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Alright, so then we plot a bunch of those points, connect to the dots, and draw the line. Okay, so practical domain. So when we're thinking of domain, remember those are the X values. So X values here represent bracelets, how many bracelets she sells. So when it says practical, it means what makes sense. And when you think about the number line, it doesn't make sense to sell negative bracelets, right? So the least number of bracelets she could sell would be 0. So the domain starts at 0, and then we don't really put a cap on how many she can sell, so this infinity kind of represents just like a, we don't know how many, so we're just going to say infinity. Now, for the practical range, so that is the y values. So we're saying, well, what's the lowest y value you can have? Well, look at this graph. She's never going to be more in debt than $100, right? She's either going to start with the debt of $100 and then just not make any money, or she's going to start with a debt of negative $100, or a debt of $100, and then she'll make money, so her profit will increase. So the practical range would be from that negative $100 to infinity, however much money she makes. Now the x-intercept here we can see is at 5, 0. And if we want to figure out how many bracelets she would have to sell to make $700, we set the profit equal to 700, 20x minus 100, have 80 equals 20, or 800 equals 20x, excuse me. So x would equal 40 bracelets that she'd have to sell. And that would be your answer for that. Okay, so hopefully that helped.